Okay, so the equation of the hyperbola has center 3, 2, focus negative 2, 2, and vertex 6, 2. And they're giving us like the general setup. They want us to find the A, B, C, and D. The A and the B are the numbers down here, and the C and the D are the numbers for the center. Okay, so, well, they're telling us the center is 3, 2. So we know what that means. That's x minus 3 squared over some kind of a squared, and y minus 2, oops, make that a little better, squared over b squared is 1. So we know that much. So we know the c, there's the c, has got to be 3, and the d has got to be 2. Now careful, you might think negative 3, negative 2, but remember they already have a minus built right into this template, this model, this setup. So that means they want whatever comes after the minus sign to be c. 3 is what comes after the minus sign. So the c does not include the minus sign, it's just what comes after the minus sign. So it's the 3, and the d does not include the minus sign, it's what comes after the minus sign, which means it's just 2. See how that works? They do that a lot in math and science formulas. You have to carefully observe what they're saying. They're saying, I want C to be whatever comes after the minus sign. That's C. So that's just the 3. And D is just what comes after the other minus, which is just the 2. They're just regular 3 and regular 2. All right, so we got C and D. So now we got to find A and B. So how are we going to do that? Well, probably a little bit of a graph would help us get going on this thing. So let me draw a little bit of a graph down here. I don't think we need a lot. So what are they telling us? The center's at 3, 2, over 3, up 2. There's the center. Focus back to up 2. So I'll put a focus, whoops. Kind of messing up there a little bit. There we go. Focus point here, center point there. This is back 1, back 2. This is over 1, 2, 3, up 1, 2. And I don't like the way I did that down there. Let me do that a little bit better. Yeah, I'll just leave it. There we go. All right. And so the vertex is 6, 2. So 4, 5, 6, 2. Right there is the vertex. Okay, so what does that mean? Let me get rid of these guys here and put back in this line there. Okay, so we've got a vertex, a center. How does this graph look? Well, vertex, if it's what is it? It's 1, 2, 3 this way to the vertex and 1, 2, 3 the other way to the vertex also. So this has got to be the other vertex point. Does that make sense? Because from the center, it's the same distance both ways to the vertex. So that's where the branches are. There's one branch here, and there's one branch there. And the focus point, that's inside the branch. Focus points are always inside of a branch. So that's generally the way this thing looks. There's some kind of dotted box here, which I'm not bothering to show. I don't know exactly how tall it is. I don't care. So there's some kind of box there. There's asymptote lines, whatever. The branches always hit the vertices, the vertex point. And so that's where those branches must be. I found the one at 6, 2 there. And so then that was 3 to the right of the center, so the other one was 3 to the left of the center. All right, so now let's get back to business. We're trying to find what A and B are underneath. Well, A is how far right and left from the center. How far right? Well, that's 3, and minus 3 the other way. So this A must be 3. So I got A. A must be 3. That's how far right and left. Now B, so that's A. B is how far up and down. I don't know. I just drew this box at random. I don't know. But what I do know is I do know the focus equation. Remember that equation? The focus equation. So whenever they give us the focus points, we're going to have to use the focus equation, which is the Pythagorean theorem, remember? So it's easy to remember. Whatever, it's just like the ellipse, except it's opposite signs in both cases. So for the hyperbola, we start with a minus sign. In the original equation, it's opposite in the focus equation, it's plus. And then if this thing was a ellipse starts with plus in the main, and ellipse would have minus in the focus equation. So it just reverses both of those. Okay, so there's the focus equation. A, we know, we already got A is 3. It's 3 squared plus B squared. Now, do we know C? What is C? C is the distance from the center to the focus. In all ellipse and hyperbola equations, C is the distance from the center to the focus. How far is it from the center to the focus? Let's count it. 1, 2, 3, 4, 5. That's 5. So C must be 5. You could put -5 if you want. Whatever. Squared, it's going to be positive 25. Solve for B. Let's subtract 9 from both sides. B squared is 16. Root it. B is 4. B is 4. There we go. That's how they got these answers, 3, 4, 3, 2. So it's all about that focus equation. Put that in your notes. For the hyperbola, the focus equation has a plus. Minus in the original, plus in the focus. Ellipse, it's just the reverse. Plus in the original, minus in the focus.